Welcome to the Joint Lecture Series in Mathematics and Mathematics Education 2025. Mathematics Podcast, a collaborative academic event between Universitas Persatuan Guru Republik Indonesia Semarang UPGRIS, Indonesia, and the University of Economics and Pedagogy, Karshi City, Uzbekistan. I am Agnita Siska Pramasdyahsari to be your moderator for this auspicious occasion. First, let us express our gratitude to God Almighty for His blessings, allowing us to gather today in good health. Before we proceed, I invite everyone to take a moment for reflection. Regardless of our beliefs, let us join together an moment of silence, according to our tradition, to center of our minds and hearts. Now, let's pray. Ladies and gentlemen, without further ado, now let's take a moment to honor our country with a rendition of the Indonesian national anthem, Indonesia Raya, followed by Uzbekistan's national anthem. You for that inspiring rendition of the national anthem for both countries. Ladies and gentlemen, to formally start this event, we have the honor of listening to welcoming remarks from our distinguished guests. Now I have the pleasure to introducing Associate Professor Dr. Supandi, the Dean of the Faculty Education of Mathematics Sciences and Technology Information, will share his valuable insight in these opening remarks. Please welcome Bapak Dr. Supandi.
Assalamualaikum warahmatullahi wabarakatuh. Wait a minute, everybody. Good afternoon, ladies and gentlemen.
Good afternoon.
Special Director Internal Affairs, Dr. Jahwan. Good afternoon. Respected to speakers, Prof. Davron Juraev from University of Economic and Pedagogy, Karshi City, Uzbekistan, and Prof. Dewi Wulandari from University UPGRIS Semarang, Indonesia. Thank you so much for your coming in this activity in this seminar. Esteemed participant of this lecture series, whom I am proud of. This lecture activity is a great significant as it serves as a platform for exchanging knowledge and experiences from distinguished speakers for all of us. I hope that activity like this will become a part of our culture, ensuring the continuous development of our knowledge, of course. The impact of will undoubtedly lead to advancement in scientific research and publication of the. A special thank you for the host from the Mathematics Education Department of PJ University Semarang. Thank you so much for the host today. I think that I will to say congratulations to all participants of the lecture series. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Supandi, for your enlightening word. We truly appreciate your presence and the wisdom you have shared. Ladies and gentlemen, now we are at the end of the opening session. Let's capture this memorable occasion with a group of photos. Please get ready. And on the count of 3, let's smile for the camera. 1, 2, 3, cheers. For the next slide. 1, 2, 3. All right, thank you. Thank you for gracing this occasion with your presence. Distinguished speakers, esteemed participants, and dear colleagues, I am honored to moderate today's International Joint Lecture Series in Mathematics and Mathematics Education 2025. Without further ado, let us begin the plenary session with our distinguished keynote speaker that filled with innovation, collaboration idea. We have 2 incredible speakers who will share their expertise. The first one is Professor Dr. Davron Aslonqulovich Juraev. He's from University of Economics and Pedagogy, Karshi City, Uzbekistan. Our second speaker is Assistant Professor Dewi Wulandari. She's from Universitas Persatuan Guru Republik Indonesia, Semarang, Indonesia. Each speaker will have 20 minutes for their presentation, followed by a discussion session. Before we begin, I want to remind all attendees about webinar etiquette. Let's ensure a smooth and respectful virtual environment for everyone involved. First, please keep your microphone mute when you are not speaking to minimize background noise, and ensure clear communication during lectures and Q&A session. Second, feel free to use the chat feature to ask questions, share resources, and engage in relevant discussion. I will monitor the chat and address any queries or concerns. Lastly, let's maintain a professional and respectful atmosphere by avoiding disruptive or offensive behavior. Embrace diversity and different perspectives to create an inclusive and welcoming environment. Thank you for your cooperation. Ladies and gentlemen, now let's continue with our program. We will introduce our first speaker, Professor Dr. Davron Aslonqulovich Juraev, with the topic title Application of Ill-Posed Problems in Nature and Technology. But before we proceed, let's take a moment to familiarize ourselves with Professor Davron's remarkable background. All right, could you please share the CV for Professor Davron, please, Miss Vivi? All right. Professor Dr. Davron Aslonqulovich Juraev is a distinguished mathematician specializing in differential equation and mathematical physics. Holding a PhD in physics and mathematics, he has an extensive academic expertise, having served as a lecturer, senior lecturer, and associate professor at various universities in Uzbekistan. Currently, he is the head of Department of Scientific Research, Innovation, and Training of Scientific Pedagogical Staff at the University of Economics and Pedagogy, Karshi City, Uzbekistan. He has contributed significantly to the field through numerous research publications, editorial roles in international journals, and leadership in scientific projects. His expertise spans multiple languages and interdisciplinary collaborations across mathematics and applied sciences. Please welcome Professor Davron and Dr. Sohjahon to deliver the insight.
Assalamualaikum everyone. I am
Waalaikumsalam.
Waalaikumsalam.
Thank you. I am Shawjahan Abdurrahim from University of Economics and Pedagogy, Uzbekistan. Well, I'm going to represent my university instead of Davron Juraev because of health problems of him. I wish you good health to the Professor Davron Juraev. So, can I present my presentation right now? And then thank you very much for inviting and to organize such kind of beautiful event because we have been working with your university and I know very well Professor Megan Ovita because we meet each other in Turkey in such kind of things and you are doing great. Thank you very much for all of them. And then I'm going to present my presentation. Well, I'm going to find the
Okay.
Yeah. That one. Is it okay if I present the presentation instead of Davron Juraev because he's a little bit sick? I mean, the sore throat. He's a sore throat.
Yes, please, Dr. Sir. Thank you.
Yeah. The theme of the PPT is application of ill-posed problems in nature and technology. Well, can you move on? I mean, the next slide. Well, the overview is I am going to talk about the first one is ill-posed problems and then application of ill-posed problems in nature. and then application of ill-posed problems in technology. And after that, I'm going to speak a little bit about conclusion. Well, what's ill-posed problems? Ill-posed problem is the context of equations of mathematical physics as problems that doesn't satisfy the criteria of Hadamard's definition of a ill-posed problem. According to Jacques Hadamard, a problem is ill-posed if it satisfies the following three conditions. First one is existence, the second one is uniqueness, and the third one is stability. Well, next slide, please. Well, there's written about the examples of ill-posed problems in mathematical physics. Well, first one is inverse problems. The second one, backward heat equation. And then Cauchy problems for elliptic equations and tomographic reconstruction. Next one, please. Well, application of ill-posed problems in nature. Ill-posed problems are common in nature, especially in areas where we infer hidden or past states from incomplete or noisy data. Here are some key applications. Well, first one is climate and weather modeling. In it, we have a climate reconstruction and weather prediction. And then the second one is ecology and environmental science. Well, and in it is the species population estimation and ecosystem modeling. The next slide, please. Pollution source identification. The third one is about geophysics and earth sciences. We can talk about in the geographics and earth science is seismic imaging, tsunami source inversion, and groundwater flow modeling. Well, the fourth one is evolutionary biology and genetics. We can talk about it. Phylogenetic tree reconstruction, DNA ancestry estimation. The next slide, please. And fifth one is astronomy and space science. And we can talk about it is exoplanet detection, cosmological parameter estimation, and black hole imaging. Sixth one is animal behavior and migration. Tracking animal movements, you can see the tracking animal movements, and communication signal processing. Application of ill-posed problems in technology. Ill-posed problems are widely encountered in technology where incomplete, noisy, or ambiguous data must be processed to extract the meaningful information. Here are some key applications. The first one is artificial intelligence, machine learning, then learning for inverse problems, regularization in neural networks, reinforcement learning in robotics. Next slide, please. The second was image processing, computer vision, and image super resolution. Object recognition in noisy environmental and facial reconstruction. And third one is going to be cybersecurity, cryptography. In cybersecurity and cryptography, we can talk about intrusion detection, description, data recovery, fingerprint biometric recognition. Fourth one is telecommunication signal processing. In it, we can talk about echo cancellation in audio processing, compressed sensing in wireless communication, speech enhancement in noisy environments. Fifth one is robotics autonomous systems. In it, we can talk about simultaneous localization and mapping, trajectory optimization and drones, self-driving cars, human motion capture reconstruction. Next slide, please. Sixth one is medical technology, healthcare. Seventh is computational finance, blockchain. Next one. Before conclusion, I want to say something. Well, if there is a Professor Davron Juraev, the presentation would be very perfect. Sorry for that. So I'm just reading the presentation because of some problems. I mean, I was not fully prepared for that. There was such kind of problem. Well, conclusion. Ill-posed problems are prevalent in both nature and technology, arising when data is incomplete, noisy, or ambitious. In nature, these problems appear in environmental science, geophysics, biology, and astronomy, where researchers must infer hidden information from indirect measurements. In technology, ill-posed problems impact AI, medical imaging, robotics, cybersecurity, and communication, where stable solutions are essential for innovation. To address these challenges, regularization techniques, Tiffin regularization based on inference and machine learning play a crucial role in stabilizing solutions. Thank you for your attention. The presentation was a little bit short. Thank you for organizing such kind of event. Thank you one more again.
All right, thank you so much, Mr. Abdurrahimov. I think we have to wait for Ma'am Agnita because she is still doing prayer.
Thank you very much, Dr. Soh and Professor Davron. Thank you, Mom Dewi, for handling during my praying. I'm sorry. Okay, ladies and gentlemen, now let's shift our focus to the second speakers. Our second speaker, she is Dewi Wulandari. She's an assistant professor from Mathematics Education Department, UPGRIS, Indonesia. She will share insight on the Mardia Skewness of assessing normality assumption in regression. But before we proceed, let's learn a bit more about Associate Professor Dewi Wulandari's remarkable background. All right. Dewi Wulandari is an assistant professor in mathematics education at UPGRIS, specializing in statistics, probability theory, and real analysis. She holds a bachelor degree from Universitas Diponegoro and a master's degree from Universitas Gadjah Mada. Her research focuses on statistical modeling, mathematical problem solving, and education. She has authored numerous publications on mathematical thinking, probability, and learning methodologies. Additionally, she has been involved in various academic and professional projects, including curriculum, facilitation, student supervision, and editorial roles in journal academic. Her contribution extends to training and mentoring educators in effective use of technology and statistical methods. All right, please welcome Assistant Professor Dewi Wulandari to deliver your insight.
All right. Thank you so much, Ma'am Agni. Is my voice clear?
That's good.
All right. Thank you so much. Thank you so much for having me. Thank you so much for giving me the opportunity, giving me the time, maybe to deliver little thing about regression, especially in normality assumption. So let me share my presentation. Can you see my presentation, Ma'am Agni? Okay, thank you so much.
In that, Mom.
Okay, okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, hello everyone. Good afternoon. I am Dewi Wulandari, and today I will deliver my presentation about Mardia Skewness and kurtosis for assessing normality assumption in multivariate regression. Okay. What we're going to discuss today, maybe I will discuss about a little bit about why normality assumption is very important, and then I will show you a little bit about skewness and kurtosis, and then next I will discuss with you about multivariate regression, and the last is about the Mardia skewness and kurtosis in multivariate regressions. So maybe I will focus in the procedure, how to use Mardia skewness and kurtosis for assessing the normality assumption when we use multivariate regression analysis. Okay, so this is what happened. These are what happened when we violate the normality assumption. First, maybe we can distort the significance test. Significant test here means the hypothesis test. And then number two, there will be a detrimental effects to the result. And then maybe we will get the invalid inferential statements. And then maybe we will get the inaccurate predictions. So this is why we have to fulfill the normality assumptions when we use the regressions analysis. Okay, next, this is the skewness and the kurtosis. Maybe a bit I will deliver because I think most of you are very familiar with this thing about skewness and kurtosis. So maybe I will recall a little bit. In univariate case, skewness is a measure of asymmetry of the distribution of variable. The zero value of skewness shows that the data follow the normal distribution, and any symmetric data should have skewness near zero. Positive value of skewness indicates that the tail on the right side is longer than left side, and vice versa. That was skewness. And then now we'll go to the kurtosis. Kurtosis is the measure of a thickness of distribution. The data will have high kurtosis value, will have heavy tails, and the kurtosis is known as leptokurtic kurtosis. Meanwhile, kurtosis with the opposite condition is defined as platykurtic kurtosis. The figure side shows us the thickness of the distribution. So we can see the high curves shows the leptokurtic, so it's not normal kurtosis. And then the lower curve shows the platykurtic kurtosis, and it's not normal. And the normal kurtosis is showed in the middle curve of the figure. All right, now if we have the data set x1, x2 until xn, then the statistic value of skewness and kurtosis test are shown as the expression Zs and Zk. Zs is the statistics value of skewness, and Zk is the statistics value of kurtosis. Okay, these are the expression or the formula we want to find the statistic value of the skewness and the kurtosis. Okay, next. When we will reject the null hypothesis, which means the sample distribution is non-normal. So when we reject the null hypothesis, it means our sample distribution is non-normal. When we reject the null hypothesis, it depends. If our sample size is less than 50, and then we find that if our z-score less than 1.96, then we don't reject the null hypothesis. It means that our sample distribution is normal. If our sample size is between 50 and 300, and then our z-score less than 3.29, then we don't reject the null hypothesis. And if we have large sample sizes, which is more than 300, then we do not see our z-score, but we see our absolute skew value. Let's see which one is our skew value and which one is our absolute kurtosis. So everyone, this expression is the skew value, and this one is the kurtosis value. So we do not see the z-score, but we see the skew value and the kurtosis value. When we have the absolute value, the absolute skew value is less than 2, or absolute kurtosis is less than 7, then we don't reject the null hypothesis. So our sample distribution is normal. So now next, let's see the multivariate regression. I think all of us here very familiar with this model, linear regression model, right? This is a function of y, and then we have beta 0 that is the intercept, and then we have beta 1, beta 2, to beta k, that was the regression coefficient, and then we have the epsilon, that was the residual, and then we have what else? We have x, x1 until xk, that was the predictors variables. This is the multiple linear regression model. What if we have 2 or more response variables? What if? This is what we have, multiple linear variables. This is the matrix. Okay, I think it's easy. I think it's easy to to convert this y to this matrix form. So when we have the data y, of course we have the data y1, and then we have y2, and then we have y3 until yn, right? And then we have this x, and then we have this x1, and then we have the xk, because this is multiple. So I think the predictor variable should be more than one. And this form can be written to this form. And this last form, this last matrix form, we can transform it, become the multivariate regression. So when we have the y is only one column, and then we have two columns here. So this is why we call it, this is the multivariate regression, because we have more than one response variables or dependence variables. I hope you can imagine how the transform from the multiple linear variables become the multivariate regressions. Okay, so next, this is the Mardia Skewness and the kurtosis. We have two formula here. P12 here express the multivariate skewness. And this P2, 2, this is the multivariate kurtosis. And this EI, EI, yeah, this is the matrix of residuals. Why this is I? Because this residual depends on the variates. Here, if we have two variable of the we have two response variable, then we have bivariates residuals like this. So the EI we have E1A and then E2I. It means we have two residual here. We have two array of residuals here. All right. And then we have S here. What is S? S denotes the covariance matrix. And this covariance is really easy to calculate by using the Microsoft Excel. All right, so this is the formula, and then we use it to find the multivariate skewness and multivariate kurtosis. So next, let's try to apply this Mardia Skewness and kurtosis to a multivariate regression. Okay, let's say we have the cognitive score of mathematics, the cognitive score of student, the student cognitive score of mathematics. It's denoted by Y1, and then we have student affection score of mathematics. We have Y2, which we take 148 students here. So we have 148 samples here. And then we have four predictor variables here. They are parent salary, and then teachers' experience in years, and then affection and cognitive of student for their lower grade. And then by using this recent expression or recent formula, and then we have our multivariate skewness, and then here our multivariate kurtosis. How do we calculate this? Of course, you can use many tools. You can do it manually by using calculator, or maybe you can use a Microsoft Excel, or maybe you can use any statistics program like R and then SAS or SPSS or many more. And then what do we do next? We have to find the critical value. We have the multivariate skewness, and then we have to find the critical value. How to find these critical values? We have to use the Mardia's table. So let's see the Mardia's table here. Okay. Mom Agni, can you see it clearly? Can you see my table clearly? Because I think it's pretty small.
It can be seen clearly, Mom.
Okay, thank you so much for the confirmation. All right, so this one is the critical value for Mardia's, for skewness. And this is the critical value for the kurtosis. Okay, let's see. Here we have alpha and we have n. Okay, let's say we take 5% for the alpha. And then we know before that we have 148 for the n, but we don't have 148 in this table. So we have the close value is 150. And then just take the intersection of these two values, and then we have 0.4 here. So the critical value of the skewness is 0.4. What about the kurtosis? Okay, let's do the same thing. Take the n and take the alpha. But in kurtosis, we have the upper and we have the lower. Okay, for the upper, we have 9.027, and for the lower, we have 6.972. What do we next? If we have this critical value of skewness and kurtosis, we will take the conclusion. We will show a conclusion. But what's the rule? The rule is for skewness here. I write it down here. For skewness, the sample will follow multivariate normal distribution if the statistic value is less than the critical value, while the kurtosis, the sample, will follow normal distribution if the statistic value is between lower and upper critical value. So let's see here. All right. So here we are. For the skewness, in our case, our statistic value is 2 point something. And then for the critical value is 0.4. And here we know that statistic value is greater than the critical value. And for the kurtosis, the statistic value is 11. And absolutely, this is not between the lower critical value and upper, because this is greater than the upper, even greater than the upper critical value. So what we can conclude here, our multivariate regression model violates the normal assumption. Okay, so what's going on? Yeah, I think we can say that because this assumption is violated or unfulfilled, so maybe we will take this risk. Maybe we distort the significance test. Maybe there is a detrimental effects to the result. Maybe we will get the invalid inferential statements or inaccurate predictions. So that's all, I think. Ma'am Agni, thank you so much, everyone. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. An awesome presentation. Thank you, Assistant Professor Dewi Wulandari, for your insightful presentation. Now, ladies and gentlemen, we are coming to the question and answer session. Please, I would like to invite all participants to ask or discuss about the topic that has already delivered by Dr. Soch and Dr. Dewi Wulandari. Maybe you can raise your hand in the chat feature or drop your message, your question in the chat box. And I would like also to inform to all the participants that we have a question. We have a attendance list to be filled. And now we have a question from Ma'am Rina Octavianti. Thank you, Ma'am, for coming and join this lecture series. She's from Universitas Serang Raya. She asking about, all right, thank you for the insightful presentation, Dr. Soch, Jahon, and I am Rina from Universitas Serang Raya. I have a question to deepen my understanding. How do you define an ill-posed problem specifically in the context of mathematics education? And how does it differ from other fields like physics or data science? Thank you. Okay, thank you, Ma'am, for your question. Maybe Dr. Soh or Professor Davron could respond this question, please.
Oh, well, Professor Davron is going to respond the question. Well, I think he can speak, but he can write the answer.
All right.
Is it okay?
Yeah,
Professor
that's
is going to
wonderful. Okay.
answer the question.
Yes, Professor Davron will write the answer through the chat box,
Yes.
Ma'am Rina. All right. While waiting for Professor Davron answering the question from Ma'am Rina, okay, we would like to open the next question maybe. And I would like to remind another participants to fill the attendance list to claim your certificate of recognized. I would like also to appreciate all the participants from Sri Lanka, Uzbekistan, and colleagues from Indonesia as well. Thank you for joining us this afternoon. All right. Okay. So, okay. We have another question from Desti Sila Silviana. All right. To Miss Devi, explanation earlier, what is the difference between skewness and kurtosis? How this concept applied in mathematics educational research? Maybe while we are waiting for Professor Davron, could you please answer this question, Ma'am Dewi? So what is the difference between skewness and kurtosis and how it is applied in mathematics educational research?
Can I answer it now?
Sorry?
Ma'am Afli, can I answer it now? Or maybe
Yes.
after Prof. Davron answer the first question?
I think you can answer it right now, Ma'am, while waiting for Professor Davron.
Okay, all right. Thank you so much, Miss Desti Sila Silviana, for the question. What an interesting question. The difference between maybe the ordinary skewness and kurtosis, right? This one for Mardias. So if for the skewness and kurtosis that we have known before, it's for the univariate, and Mardias is for the multivariate. So that's different. And then how these concepts applied in mathematics educational research. Of course, it can be applied in many fields, not only the mathematics educational research. If you use the multivariate regression analysis, then you have to check the normality assumption, right? In any field. mathematics education, or maybe in economics, or maybe in psychology, and maybe in medical research, if you use or maybe you applied the multivariate regression, then you have to check, and you can use this Mardia Skewness and kurtosis. So that's all. Thank you, Ma'am Agni.
Right, great. Thank you, Ma'am Devi, for your explanation. I think this is good for the students in the undergraduate, for the freshener that they have already got statistic a course in this semester to know more about the skewness and kurtosis, and then they know about this concept not only applied in mathematics only, but also for any fields like what Mom Dewi explained to us. Okay, and then we would like to read the response, the answer from Professor Davron. Okay, this is the response from Professor Davron to Mom Rina. Ill-posed problem in mathematics education. In mathematics education, an ill-posed problem is one that lacks clear condition for a well-defined solution. So this is kind of interesting topic, Ma'am Rina, like we do not have a clear condition about well-defined solution, right? This typically means that a problem, there are at least three lacks of unique solution. It can be multiple answer may be equally valid. And the second one is not well specified, means that the problem statement may be vague or missing critical information. And the third one is lacks stability. This is the small changes in input can lead to drastically different solutions. In contrast, a well-posed problem, so we have ill-posed problem and well-posed problem. So this is quite interesting and new for me particularly. And we may think about what's that? The solution that should be unique and should change continuously with the input. And then the further information from Professor Davron, it'll pose problems in different fields. All right. So he provided us three kind of different fields implementation. One in mathematics education, the second one in physics and data science. So let's have a look in mathematics education. This is often arises in open-ended questions. So this is kind of typical question that what we are supposed to create in assessing the students' competence in mathematics, right? And we use real world application or when students must interpret an ambiguous problem statement. For example, find a pattern in this sequence without specifying constraints. All right. This is kind of ill-posed problem in mathematics education, right? So we do not have any real world application to know about the context, but the question asking about find a pattern. All right. Okay, I got the point. And the second one, this is in the implementation on physics fields. Ill-posed problem occur in inverse problem. Maybe any other participant come from physics education, maybe. The example showing to us about the determining an object from its gravitational fields. This require regularization techniques to obtain stable solution. And the last example that provided by Professor Davron is in data science, often seen in underdetermined systems. For example, many features but few observation, missing data, or cases where predictive model lack sufficient training data. And then, okay, regularization and additional constraint. All right. Particularly, Professor Davron also provides some few example. Maybe any response from Ma'am Rina, please? If you would like to ask directly, maybe, Ma'am. Okay. Professor Davron also provide us with a few example of ill-posed problem in mathematics education and how it can be compared to well-posed problem. Okay, that's interesting to be discussed, ladies and gentlemen. So there are three well and ill-posed problem that has already provided in the column chat. The first one is open-ended word problem. Okay. And this is related to find the next number in the sequence 2, 4, 8. And the second question, geometry problem with missing information. The ill-post like find the area of this triangle without specifying side length or angle. So how to create the well-post problem. Find the area of a right triangle with legs of length 3 centimeters and 4 centimeters. All right. Okay. Or using the real world application with multiple interpretation. It can be design a bridge that is strong and cost effective. Oh, this is kind of example of ill post. Okay, so how to develop the well post? Design a bridge using at most 1,000 kilograms of steel that can support 10,000 Newton of force. Okay, this version includes precise constraints. Okay, well defined. Thank you, Prof. Davron. Oh, I think Mamrina already respond. That's superb. Okay, thank you. All right, ladies and gentlemen, we still have any question in the chat box from Zulfa Izati Prisanto. Okay, excuse me, my question for Mr. Sohajon. Okay, I am Zulfa Izati from UPGRIS. Okay, she's UPGRIS students. How do ill-posed problems arise in cybersecurity and cryptography? Oh, right. It is interesting in the digital era and then in the cybersecurity. Okay.
Thank you for your question, Zulfa Izzati. Well, the professor is going to respond the question also. He's going to write in the chat.
Okay. Okay, thank you, Dr. Sok. And we have another question. Okay. Another question from Rahma, also UPGRIS students. Why is MRI image reconstruction categorized as an ill-posed problem? Okay. This is maybe quite new for us, for our student as well, discussing about ill and well-posed problem, but it is really interesting to know more and explore how we could change the ill posed question into well-posed question. All right. We got a response from Professor Davron. Okay, MRI reconstruction as an ill-posed problem is categorized as an ill-posed problem because it often violates one or more of Hadamard's well-posed criteria. So there are three criteria. The first of all, lack of unique solution, as we has already explained before, right? Instability and incomplete or missing data. So it talking about the missing data, the missing information, something like that, I think, right? Okay. Okay, so the result is an infinite number of possible reconstruction. All right, thank you, Professor Davron, for your response. Anything else from any other participants or audience would like to discuss about the statistical, about the normality assumption that has already delivered by Mam Dewi and talking about the ill-posed problem? All right. Maybe Dr. Sir or Mom Dewi has any thought would like to discuss regarding to our topics this afternoon? Oh, this is the reminder from the committee to fill the attendance list. Okay, we have another question, Mom. Okay, to ask about the results of our. Okay, so Mom Dewi, today's lecture is attending by the students who taking statistic course. So they have to ask about the topic that you have delivered about statistic, skewness and kurtosis. And ini I think Gita's group has a question like, okay, how in the research of education, how influential is Mardia Skewness in helping in learning to analyze data? Maybe you can enlightening them to think about how it can be used in analyzing data in their their mathematics education article maybe or project or something like that. Yes, please, Ma'am Dewi.
All right, thank you, Ma'am Agni. Thank you so much for the question, Miss Gita Widya. So the question is how influential. I think it's important. Mardia's skewness and kurtosis is quite important, I think. Quite useful for us in analyzing data because uh, every parametric test needs uh, needs a full field of normality assumption. Every parametric test. So I think it's really useful. This Maria Skewness and kurtosis in assessing it will really help us to, analyzing data, of course. So I think, Mom Agni, if the question is how influential is, it's really important and useful.
All right, Ma'am Dewi, thank you very much for your response. I think Gita's group has already receiving the information whether the influence of the Mardial itself for educational study or analyzing data is pretty important for the analyzing the data. So we are going to the respond in the chat box from Professor Davron to cybersecurity and cryptography. Let's have it. Okay. Ill-posed problems arise in cybersecurity and cryptography when a problem lacks a unique solution, is highly sensitive to small changes, or doesn't have sufficient information for a stable answer. These issues often appear in encryption. So it commonly happen, right? Key recovery and security. What's that? Security analysis due to the mathematical complexity and adversarial nature of this. What's that? Of this field. So there are key recovery, password cracking, and then cryptanalysis and side channel attacks. Wow, that's wonderful. That's closely related not only in mathematics but also in information technology, right? Okay. Professor Davron also add more some information related to the anomaly detection in cybersecurity. Okay. The example is identifying if network traffic contains malicious activities, while ill-posed, the boundary between normal and malicious behavior is not well defined. Okay, thank you. Miss Yulfa Izati also has already respond for the explanation from Professor Davron. Thank you very much. We will check again if there are any other question. Okay, thank you from Rahma and Zulfa. All right.
Well, I have
I
a
think-
question. Sorry.
Yeah, Dr. So,
Well, I have a question for Professor Dewi Wulandari. Well, what can you say about the application of your research in other sciences?
all right. Thank you, Dr. Soh. Would you like to respond, Dr. Soh? Question, Mom Dewi?
All right. Thank you so much for the question, Dr. So. Dr. So, maybe you can repeat the question, please.
Well, what can you say about the application? I mean, the application of your research in other sciences.
Oh, okay,
What
all right.
application?
Okay, thank you so much. This Mardia Skewness and kurtosis can be applied in any really usable. It can be applied in any fields because I think multivariate regressions is used in not only in mathematics or statistics but also in any kind of case in any fields. So maybe like in psychology, we want to know the influence of maybe what in psychology, maybe one behavior to another behavior. We can use this multivariate regression, and of course, when we use this multivariate regression, we will check the normality assumption, and we can use this Mardia Skewness and kurtosis.
Thank you.
I think that's all. Thank you so much,
Thank you.
Mr. Abdurrahimov.
Wow, what an awesome discussion then. Thank you, Mom Dewi and Dr. Soh and Professor Davron. Like what Mom Rina said in the chat box, there are numerous research ideas emerging here. Yes, hopefully all the participants can taking a benefit from this scientific discussion this afternoon. And we still have 1 more minute to have question, if any. All right.
Maybe from me, Miss
All right,
Ma'am
yes,
Agnita.
please. Yes, please, Mom Dewi.
All right, thank you so much. Mr. Abdurrahimov, what subject? Are you a teacher?
Yeah, I am head of the Department of International Relations.
Oh, international
Yeah,
relations?
he is the coordinator of the
Oh, so
international
you-
affairs.
And also-
oh,
And also PhD student.
oh, PhD student.
And
Oh,
also
right,
PhD
okay.
student. I am doing two
Okay.
things.
All
Okay, thank you.
right,
Thank you
great.
so much.
Yeah.
So that's all. Thank you, Ma'am Agni.
Thank
Okay.
you.
All right, thank
Thank
you,
you.
ladies and gentlemen, and the distinguished guests and all participants. We come to the end of the session today, but I would like to remind you again to fill the attendance list to claim your certificate of recognition. And before we end the session, we would like to handling the certificate for our awesome speakers today for Professor Davron and Mom Dewi Wulandari. Could you please, Miss Vivi, to slide the certificate? Okay, before we, okay. Bapak Dekan, are you still here? No, I think. Okay, we would like to handling the certificate of appreciation to our speaker today. Thank you for your insightful explanation, Mom Dewi. Kindly to receive this
Yeah, thank you so
certificate.
much.
Okay, thank you so much. And the next for Professor Davron and Dr. Soh, kindly to receive the certificate of appreciation from this lecture series.
Yes, thank you. Thank you.
Okay. Can anyone join to giving applause to our respectful speaker today? Thank you very much. Okay. All right. Congratulations and thank you for your invaluable contribution. So, ladies and gentlemen, esteemed guests and distinguished participants, we come to the end of this session. Thank you for your esteemed speaker for sharing and discussing this insightful topic in this afternoon, and to all the participants for your active engagement. With that, we officially conclude the first international joint lecture series in mathematics and mathematics education. Thank you, everyone, for your participation. We look forward to seeing you again for the next lecture series. Thank you all. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank
Thank
you.
you.
Thank you, everyone.
Thank
Thank you so
you,
much.
Dewi,
Nice to
Prof.
meet you,
Davron,
everyone.
Nice to
Thank
meet
you so
you.
much.
also
Thank
all
you,
the
Professor Dewi Wulandari. Thank you. Thank you, Professor.
Thank you.